Hello everyone, I'm Frank and welcome to episode 45 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down into detail so that you can learn how to Sudoku. Today's very easy puzzle is called Discount by Gerhardt 1963, and here are the rules. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Cages. Digits in cages cannot repeat and must sum to the value shown in the upper left corner of the cage. So, for example, these three digits must add up to 18. These three digits must add up to 22. These three digits must add up to 6, etc., etc. So an example for here could be something along the lines of, I don't know, 9, 6, and 3, right? Because these three digits add up to 18, and that's what's required by the cages. And they're usually called killer cages, but in this one he labels them just as cages. The next rule is called Renban line, usually shown as purple lines. Digits along a Renban line must form a set of non-repeating consecutive digits in any order. So, for example, this is 1, 2, 3, 4, 5, 6, 7. If you know this has a 1 in it, you would know that the remaining digits on it would have to be 2 through 7, because that's the only set of 7 digits which contain a consecutive set without repeats, remember, which contains 1, right? 1 can only be consecutive with 2, which can be consecutive with 3 or 1, but obviously 1 is already taken because you can't have a repeat. So it would have to continue up from there. It would have to be 1, 2, 3, 4, 5, 6, and 7 for all 7 digits, right? But it can be in any order, right? So you don't have to have 1, 2, 3, 4, 5, 6, 7. It could be just any order here. And that's how Renban lines work. Remember, you cannot have repeats on Renban lines, and they have to be all consecutive. Kropke pairs. Digits set in cells separated by a white dot are consecutive, and not all dots are necessarily given. So, for example, if this were a 5, this would have to be a 4 or a 6 to basically make sure that these cells are consecutive. And that's how Kropke pairs work, specifically white Kropke pairs. There's also a variant that's also called black Kropke pairs, but it's not used in this puzzle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so to tackle this, my eyes immediately drawn by the cages, because we have a 3-cell cage adding up to 24. We have 2 of them actually, and we have a 3-cell cage adding up to 6. Now the special thing about 6 and 24 is 6 requires the smallest 3 possible normal Sudoku digits to add up to it. So this specifically has to be 1, 2, and 3. And this also has to be 1, 2, and 3. While 24 has to have the 3 largest digits add up to it, right? Because you cannot have repeats in cages. So the biggest digits are 9, 8, and 7, which all add up to 24. So you cannot have any other 3-digit combination without repeats to add up to 24 in normal Sudoku. So this is 7, 8, 9, and this is 7, 8, 9. Well, notice one thing about these cages, particularly this cage and this cage. They are on a Renban line. And remember when I said that if you had a 1 on a Renban line, you would know that it would have to be consecutive all the way up to the length of the Renban line, right? It would have to be 1 through 7 in the case of a 7-length Renban line. Therefore, all of these must be 4 through 7, right? because you cannot have repeats on Renban lines, and we already have 1, 2, and 3 there. So 8 and 9 cannot be part of any 7-cell consecutive set with 1. Similarly, this is 7, 8, 9, so the rest of this Renban has to be 3, 4, 5, and 6. Right? Because it cannot have repeats in the 7, 8, and 9, and 1 and 2 are not allowed in a 7-length Renban line with a 9. So we have 2 digits which are at minimum a 3 and a 4. Well, we need another digit to add up to 8 with it, and 3 and 4 is the minimum, so that would be 7. And if you add that to 1, that would mean this would have to be 3, 4, and 1 to add up to 8, right? Because we have to have the minimum here, 3, 4, plus the minimum here to add up to the actual value of the cage, which forces this all to be the minimum. So this is 1, this is 3 and 4, which means the other digits on the Renban, since we have a 3, 4, 3, 4 pair here, in this box and in the Renban cannot have a 3 or 4. So this is 5 and 6 and 5 and 6 in this cage. Well, that adds up to 11. What digit with 11 adds up to 12? It has to be 1. So this is 1, which means neither of these can be 1. Now we have a 2, 3, 2, 3 pair in this 6 value cage. So what does this have to be? It has to be a 1 because it cannot be 2 or 3. And 1 is consecutive with 2, so therefore this is 2, which makes that a 3. Again, we said this can't be 4 here. Actually, what is the maximum value here? The maximum value here can be 6 and 7. Well, that adds up to 13. And the cage total adds up to 22. So 22 minus 13 as a maximum, and then you take the maximum digit this could be, and that would be 9. And that all adds up to 22. So the maximum possible cell for these cells have to add up to the cage. So it has to be the maximum number. So this has to be 6 and 7, and this must be 9. Well, that eliminates 6 and 7 from the rest of the Renban line. So this must be a 4, 5 pair. And again, yeah, so this is symmetric, which makes sense that this is the cage values are essentially symmetric also. Well, this cell is consecutive with both this digit and this digit. The only digit that satisfies that is 5, which would be consecutive with 4 and 6. So this must be 3, this has to be 7. This is 4 and 5, that adds up to 9, and this whole cage adds up to 18. So we have one digit adding up to 18 minus 9, which is 9. So this is 9. These can't be 9 anymore. We have a 7, 8 pair in the 7, 8, 9 cage, and therefore 7 and 8 cannot be in the rest of the cage, so this must be 9. And 9 is consecutive with 8 only, which is therefore forces this to be 7. For the rest of this box, it has to be 2 and 8 and 2 and 8. This Renban is 1, 2, 3, 4, 5, 6, 7 also in length. So this also has to be 1 through 7. So this is now 2, 3, 4, 5, 6, 7. And 7 can't be here and can't be here because of this 7. This can't be 4, 5, or 6 because of these 4, 5, and 6. This can't be 5. This can't be 3. If this were 2, it's not consecutive with 4, so this can't be 2. If this were 4, it would be consecutive with 5. If it's 6, it's consecutive with 5. Therefore, this is 4 and 6, and therefore this has to be this is 4 or 6, and this has to be a 5, which forces this to be 4. This can no longer be 5, and this can't be 5, and this can't be 3 or 4. This can't be 4 because of that 4. Similarly, this is also 7th in length of a Renban, so it has to have 3 through 8 in the remaining 6 cells. This can't be 3, 5, or 7. This can't be 3, 5, or 6. This can't be 3. This can't be 7. This can't be 4, 5, 6. This can't be 4 because of that 4. This can't be 1 or 2, so this must be 3, which means this can't be 3. This can't be 8 or 9, so this must be 7, which means neither of these can be 7. These can't be 7 here. These can't be 3. Similarly, if this were 8, this is not consecutive with any digit here. So this has to be 4, 6, which is consecutive with 5 only. So this is 5, this is 6. This can no longer be 6. This can't be 5. This can't be 3. And this can't be 3 or 4. Where is the 3 on this Renban line? The only possibility is here. So this is a 3. This can't be 7, and this can't be 7. So similarly, where is the 7 on this Renban? Can't be any of these spaces, so it must be here. So this is a 7. Now, how do we want to attack this? Maybe the rest of row 4 and the rest of row 6. The rest of row 4 is 2, 5, 6, 8. Well, this can't be 6 here. And this is 2, 5, 6, or 8. So that's fine. The remaining cells in row 6 are 2, 5, 4, and 8. But this can't be 4, so this is 2, 5, 8. And this is 2, 5, 4, 8. This can't be 2 because of the 1, 2, 1, 2 pair in column 8. So this can't be 2. This can't be 8 because of the 8, 9, 8, 9 pair in column 2. Oh, I see one way. Let's look at the rest of the cells in this box, and this box. It has to be 2 through 6 here, but this cannot be 2, 3, or 5, so this has to be specifically 4 and 6. And therefore we have a 4, 6, 4, 6 pair in row 7, which eliminates 4 and 6 from the rest of the row. This can't be 4 or 6. This can't be 4 or 6, so this is 7, 8, or 9. Well, on this Renban, we now have a 7, 8, 7, 8 pair, which eliminates 7 and 8 from the rest of the cells in the Renban. So this can't be 7 or 8, so this is 4, which makes this 6. This can't be 6 or 8 anymore, so this is 5. This 6 means this has to be 4. We should have a similar thing if we look at this, right? If we look at the rest of these cells, it has to be 4 through 8. This can't be 4, 5, 7, or 8, so it must be 6. This can't be 4 or 6. We have a 2, 3, 2, 3 pair on this Renban, which means 2 and 3 cannot be in the rest of the Renban, so this must be a 6. And this has to be a 5. Okay. The rest of this, so this has to be a 4. Again, this has to be 2, 3, 5, and 6. This cannot be 5 and 6. So now we have a 2, 3, 2, 3 pair in column 3, which eliminates 2 and 3 from the rest of the column. Therefore, this must be a 4. So similarly, well, okay, where is the 4 in this box, right? Can't be here. Can't be any of these. It must be here. So this is a 4. This can't be 6. We have a 2, 5, 8 triplet in row 4, which eliminates 2, 5, and 8 from the rest of the row. This can't be 5 or 8, so this must be 6. The rest of this has to be 5, 7, and 8. This can't be 5. We have a 7, 8, 7, 8 pair in column 7, which is, yeah, because this is exact. So this is essentially symmetric, except that one is low digits and the other one is high digits. So we should be having a similar thing. This has to be a 6, right? Because it's a high digit version of the 6. So this is 6, which means these can't be 6. Where's the 6 in this box? It has to be here specifically. So this is 6. This can't be 4. We have a 2, 5, 8 triplet in row 6, which eliminates 2 and 5 from the rest of the row. So this must be a 4. What else do we have? Where can 3 be in row 8? It cannot be any of these cells. It can't be any of these cells. Can't be here, so it must be here. So this is a 3. So similarly, we should have a 7, right, in this one. So that's a 7. Yep, so that's essentially symmetric. So these are essentially symmetrical puzzles. So let's see, what else do we have? This cannot be a 1 because of the 1, 2 pair. Where's the 1 in row 8? It has to be here. Cannot be here because of this 1. Can't be here because of this 1, 2 pair. So this must be 1. So similarly, this has to be 9. Right, this can't be 9 because of the 8, 9 pair, and this can't be 9 because of this 9, so that's 9. This then becomes 2 or 8, but we have a 5, 7, 8 triplet in row 1, so this can't be 8 anymore, so this is 2, which makes this an 8. What else is remaining? We have a 1, a 3, and an 8. Well, this can be 1 or 8. This is 1, 2, or 8, but this can't be 8. So because of this 8, 9 pair. So this is 1 or 2. We have a 1, 2, 1, 2 pair in row 2, which eliminates 1 and 2 from the rest of the row. So this makes that 8, which makes that 2, which makes that 8. This must be a 2 because of the equivalence that we had here. This is 8 or 9 also. We have a 7, 8, 9 triplet in this box. This is also a 1, 2, 3 possibility. So that means the rest of the box cannot contain 7, 8, and 9. Well, what are the remaining digits? They're 1 and 4. This can't be 4, so this must be a 1, which makes that a 4. The remaining digits here, 7 and 9. This can't be 9, so this is 7, which makes that 9. This has to be 1, and this has to be 3. Well, where's the 1 now? Well, we already know one of these two is a 1. That doesn't tell us much. One of these is a 7. This cannot be 1, 2, 3, 4, or 6. It's 5, 7, 8, or 9. But the problem is it can't be 5 because that can't be 5. So this must be 7, 8, or 9. We have a 7, 8, and 9 triplet in column 8, which eliminates 7, 8, and 9 from the rest of the column, which therefore makes this a 5. So this can't be 5. This has to be equivalent 5, right? Because the remaining digits here are 1, 2, 3, and 6. Well, this has to be 4, so therefore this is a 6, and this has to be 9, right? Because those are the only remaining digits. This can't be 6, so that makes that a 9. Yeah. So therefore, this cannot be 5, so it's 1, 2, or 3. And therefore, this is a 5, which means this can't be 5. So far, it's all pretty equivalent. This 2 and 3, they both see this cell. And it has to be different 2s and 3s. So if this is 2, this would have to be 3. If this is 3, this would have to be 2 because of the Renban line. You can't have repeats on Renban lines. So therefore, they both see this cell. So 2 and 3 are not possible in this cell. So this must be a 1, which has the equivalent to 9 here. This 1 means this has to be 2, which makes this 1, which makes this 2, which makes that 3. That has to be 1, therefore. This then has a similar equivalent on this side. So this has to be then 9, which makes that 8, which makes that 7, which makes this 9, which makes that 8, which makes that 9. Okay, so this has to be a 2 now because of the Renban. So this is 2, this is 3, this is 2. This again can't be 7, so this is 8, 7, 8. This can't be 8 or 2, so this is 5. This can't be 5 or 8, so this is 2. This can't be 2 or 5, so this is 8. This can't be 2 or 8, so this is 5. And we have just a 3 and a 7 left. And it is cool and good. Yeah, so that used essentially a lot of aspects of the Renban line, really. It focused a lot on that and sort of the symmetry of it. And using like pairs of digits, which can only be, pairs of cells, which can only be like 2 digits. We use that quite a bit. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.